everybody. Today we're going to talk about the psychology of climate change. And this is going to be a theme that's broken up into 4 different mini lectures. We're going to talk about biases. We're going to look at this idea of the tragedy of the commons. We're going to examine climate change denial. And then we'll also briefly look at grief associated with climate change. So let's get started on on biases, cognitive biases. So let me hide myself so you can see this kind of rather complicated diagram. This is an index that records sort of all the different biases that this particular group has identified. So there's like quite a lot of them you can see here. And they've grouped them into these 4 different categories of too much information, not enough meaning, need to act fast, and what should we remember. So we're going to talk about each of these 4 categories more specifically. But as a general idea for this lecture, I want you to understand that everybody has biases, and it's something that impacts us every day. Every decision that we make is sort of clouded to some degree by biases. Some of these biases are good and they help us to make correct decisions or decisions that are best for our preservation. Other biases may not be the best ones for how we perceive the world. And awareness of bias can be really helpful for you to overcome them. And so I've put a link on this page for this really fun little test you can do on your own on your computer that tests your bias for a whole bunch of different categories that you can pick from. So I've done this test for gender bias in science, gender bias in general, because I'm interested in this kind of thing. And even myself, I'm biased against women scientists, so I'm biased against myself. So it's kind of a fun little quiz to do to kind of see like the societal norms that we put on us sort of make us all have these sort of inherent biases. And the third point I wanted to mention is that biases also impact scientists, right? Scientists are human too. So they impact our ability to do science well, but they also impact the ability for the public to trust in the science that we provide. And so let's look at some of these categories. This first one is called too much information. And this is when we have information overload coming at us. So you can think of an example like when you're driving and imagine you're in a place that's unfamiliar and you're trying to navigate and find a destination. And you have your phone on that's spitting out directions. You have a backseat driver who's telling you you're going the wrong way. And you have the songs on the radio blasting really loud. I mean, there's just too much going on, and you use your inherent biases in order to kind of lead you in the proper direction. So that may mean that you trust your friend behind you in the back seat rather than trusting the GPS, or vice versa. And so these kind of biases really help us to kind of skim and filter all the information that's coming at us really quickly and allow us to kind of effortlessly decide the things that are really important and focus on those instead. And so one of these I want to talk about is called the confirmation bias, just as an example. So this is a tendency to search for, interpret, favor, and recall information that confirms one's prior personal beliefs. And you can see this in this XCD cartoon down below. You can see the example of somebody who's looking for an answer to a story and they find a link that supports their own viewpoint and they're like, yes, of course, that's exactly what I thought. And this bias has impact on science for sure, and scientists have to design experiments so that they don't just confirm their own ideas. And another example would be this example of not enough meaning. So this bias, these groups of biases help us to construct meaning from chaos. So it's a little similar to the previous one, but it's really when there's sort of gaps in meaning, we have these biases to kind of help create a mental model of something. So say, for example, your significant other begins behaving differently all of a sudden. We'll use our biases, like the one that favors people that we're more familiar with, to give that person the benefit of the doubt rather than thinking that something bad is happening to them. We also need to make sure information remains stable and accurate as possible, and this is where stereotyping comes from, and some interesting biases that influence scientific thought, including the bandwagon effect, which is in here somewhere, and I'll show you a really interesting example of the bandwagon effect. So this is the tendency to do or believe things because many other people have done or believed so before you. And this is a plot that shows different measurements of the speed of light. So the first measurements were made, I don't know when this is, 1860. and they got this point here and this large error associated with it. And you can see this was a very historic measurement because the speed of light is really important for lots of different physical applications. And the people who were leading these initial experiments were very prestigious scientists. And so even though the measurement is actually incorrect, the speed of light is this line that's at the bottom here. This horizontal line is the actual true speed of light. But even though these people were wrong, because they were so prestigious, the following studies that all came after them all mimicked the same speed. They replicated it and got the same answer. And so it wasn't until about the 1950s that people began to see that, oh, these are actually incorrect. And we started to get new technologies that allowed us to make more accurate measurements of the speed of light. So that's a good example of the bandwagon effect, which is alive and well in science. And then we get to the biases that allow us to react fast in a lot of different situations. So we need these to be able to make quick decisions. These decisions are often for our security and health and survival. And one example that we'll look at for that might be applicable to you, and then is this Dunning-Kruger effect, and we'll look at it also as it applies to the scientific community. So the Dunning-Kruger effect is an effect in which incompetent people fail to realize that they are incompetent because they lack the skill to distinguish between competence and incompetence. And this is, it's kind of a funny way to describe it, but if you look at this plot here, what it shows on the x-axis is the scores of test takers in a given class. So a class like this one, you would have the people on the top quartile, the people at the very bottom, people in the middle, and this is their actual test score. So what you'll see is that the people who are at the top quartile, the people who are high achieving in this class, actually underestimate their performance. They think that their perceived ability is less than their actual ability. But there's a real staggering difference between the lower three quartiles, where we have the actual test scores are much lower than their perceived ability. And so we have this real disconnect in people for them to be able to judge and distinguish between competence and incompetence for themselves and for peers in their class. Okay, so this is an example with a scientific viewpoint of the Dunning-Kruger effect as well. We have in this plot ice core data from Antarctica, both in blue and green. They just come from different locations in Antarctica. And they show the CO2 over the last 10,000 years. And then we have measurements that are being made every day now at Mauna Loa in Hawaii. And they began, I think, in like 1950 or so. And this was posted online. And one of the comments was, whoa, hold on a minute here. CO2 readings from one location prove we have an enormous global spike in CO2 levels? You've got to be kidding me. This is science? That would be like me taking hydrological readings at the bottom of Lake Superior and then declaring that the entire surface of the earth must be covered with water based on my readings. So the deal is that you need to trust that scientists know what they're doing. They've spent a lot of time putting data together and understanding and testing things, and they're not just putting this CO2 level out here, diagram out here, thinking that we can pull one over on people. Really, CO2 is an incredibly well-mixed gas in the atmosphere, and so measuring it at one location actually does give you a fairly decent global picture of CO2. And you have a commenter who doesn't have an education in that, who thinks that they have the competence and declares that everything else must be bunk if it doesn't go according to them. Another bias that allows us to think fast is called the Texas sharpshooter fallacy, and I kind of like this one. It says pieces of information that have no relationship to one another are called out for their similarities, and that similarity is used for claiming the existence of a pattern. And I've seen that this plot, it's actually kind of a joke plot. It's not a real plot, although the data are real. And it just shows the number of pirates. Actually, this is going down over time, and then global average temperature is going up, and you see they're directly related. And so the idea was to kind of make a joke out of the fact that just because you have two data sets that are correlated with one another does not mean that there's a cause and effect for explaining their relationship. Okay, and that also comes to light when we look at examples of individuals claiming that global warming is not happening when there's a single snowstorm event that might disprove that warming can even happen. So the idea here is that people are kind of doing the flip side of the Texas sharpshooter fallacy. Instead of having things that are correlated, they're saying like, these are uncorrelated. How can you have a snowstorm and warming at the same time? That makes absolutely no sense. And they're using that lack correlation to discount the entire idea of global warming, when in actuality, there's been a lot of studies published that when you have a warming climate, you actually can have a lot more sort of quote unquote freak events that happen, extreme events. And we'll talk about that when we get into the next section, the next module. And so this shows land and ocean temperature anomalies for a time period when this newspaper article was published, when there was indeed a very freak snowstorm that was happening in the North Atlantic, in the North Atlantic along the Atlantic coast of the U.S., even though in most of the globe, the temperatures were quite warm compared to normal. So freak events still happen, and they'll happen more, to more extremes in a warming climate, actually. Okay, then we have our last set of biases that are grouped under what should we remember, and this is because we tend to discard specifics to form generalities. We edit and reinforce some memories after the fact, et cetera, et cetera. And so our brains are kind of hardwired to filter out some information that pertain to certain events. And we often reduce memories to their key elements in order to remember them. One way of doing this is to employ the duration neglect bias. This is a bias that emphasizes smaller events as less important than longer events. So, for example, if you were sick with a cold for a couple of days, you won't remember that nearly as much as you would if you were sick with COVID for 2 weeks at home. Another example is a negativity bias. Let me go to the next page. And this is a notion that even when of equal intensity, things that are of more negative nature have a greater effect on one's psychological state than neutral or positive things. And so this kind of focuses people to remember mostly the negative aspects of life, right? So this is very true for our psychological sort of well-being. A lot of humans are hardwired to receive and to hear those negative thoughts more predominantly than positive thoughts. This is why a lot of people, including myself, see a lot of value in practicing what's called a gratitude journal, where you actually force yourself to think about the positive things that are happening in your life so that you're not weighing down on the negative side. For climate, this is a very important one because it emphasizes a responsibility we have to tolerate and respect others. If you truly want to motivate somebody to conform to addressing climate issues, then we need to be able to respect where they're coming from and not try to motivate them with fear. And there's this quote that I love here: "Fear is generally an ineffective tool for motivating genuine personal engagement." And so it's really important that we don't focus, when we're trying to convince people of climate change being real and that we need to make actions for it, that we don't focus on that really negative aspects that are going to happen, because it's only going to make people sort of pull back and be less inclined to do anything about it in the first place.